When you are condensing logarithmic expressions, you're going to take either a sum or a difference or a product of some kind of logarithmic thing, and you're going to compress it or condense it into one single logarithm. That is called condensing. So we can use all the rules, the product rule, the quotient rule, and the power rule to do this in reverse. So I just have some basic examples. These are just the rules that are printed out. We're going to go through some basic examples, and then we're going to give you some more challenging examples so you can work those out. All right, so let's start with some more basic examples. If I ask you to write as one single logarithm, first thing you're going to check for is, do the logs have the same base? And in example A here, they are both common logs, log base 10. That's the button on our calculator. So this is great. That means I'll be able to use my calculator on these. Okay, so this is a sum, which means I can put them together as a product. So you're going to keep your common logarithmic with its base, and then you're going to multiply those two numbers. So 25 times 4. So this is going to be log of 100. And that I can put in my calculator. So I press the log button and then 100, or 100 and then the log button, depending on what calculator you have. And that you should get an answer of 2. Which makes sense because 10 to the second power is 100. So it makes sense that it would be 2. All right, so just know you can utilize your calculator whenever there are numerical values in there, which is nice. And again, the calculator only has the log base 10 button, which is the common log, and the log base E, which is the natural log button. So those are the only two that you can use on your calculator. All right, let's look at example B. Example B, again, we have common logs for both. But this is a subtraction problem, and that subtraction problem tells me it's going to be a quotient. So I can compress them or condense them together, keeping that common log, but then we're going to have a quotient here. So the numerator is the first expression, and the denominator is the second expression. So again, just using these same things that we did to expand logarithms, we're just doing the same thing, only backwards. All right, so let's get into some more challenging examples. All right, so what about this? So this is some natural logs, and notice everything is a natural log, so that's wonderful. That means I'll be able to put all these together because they have the same base. They have both base E. All right, first thing I see is that there are coefficients in front of each of those natural logs. That means I can use the power rule. So I'm going to take both of those coefficients and bring them up as powers. So the natural log of x squared, notice the 2, whoops, that is not what I wanted to happen. Let's delete that. So this 2 can be brought up as a power. Same thing with this 1/3, that can be brought up as a power. So this will be plus the natural log of x plus 5 to the 1/3 power. And then once I've got that powers taken care of, I notice I have an addition problem, which means I'm going to use the product rule. So I'm going to keep the natural log, and then I'm going to multiply these two things. I'm going to multiply the x squared times the x plus 5 to the 1/3 power. And in my world, that's a perfectly acceptable answer. A lot of textbooks do like you to change back into root form with those 1/3 powers. So you would rewrite this as the natural log of x squared times the cube root of x plus 5. So this answer or this answer, both correct. Personally, I like the exponential notation. Some people like the root notation. It's just a personal preference thing. So, but both of them are correct. All right, then we can start getting into more advanced problems where we have more sets of parentheses. So you really have to think about these. And I usually attack these as if they are order of operations problems. So I always look inside the parentheses to see what I can do. So if you look inside that first set of parentheses, I can put this together. They are both log base 8. It's an addition, so that means I can use the product rule. So this will be 1/2 times the log base 8 of x times y, right? I can put those together as a product. So I like to get rid of the parentheses if I can. Over here, the x plus 4, there's nothing I can do with that. That's just x plus 4. All right, so then I see that I've got powers. So I've got this power that I can move up, and I've got this power that I can move up. So this is going to be log base 8 of xy to the 1/2 power. And notice all of x and y is big. That whole thing gets the power. minus log base 8 of x plus 4 to the 6th power. So got rid of those powers. Excellent. All right, then I see I have a subtraction sign, which means I will have a quotient. So this is log base 8 of all of this stuff. xy to the 1/2 power is my numerator, and then my denominator is x plus 4 to the 6th power. And again, your textbook may want you to write that as a root. So your answer would be log base 8 of the square root of xy divided by x plus 4 to the 6th power. Some people just prefer the root notation. It's entirely up to your professor. It's very subjective. I prefer the exponential, but it works both ways. Anyway, so hopefully that helps you with condensing. Again, smushing it, that's the whole point of condensing. It says condense. You want to take something long and compact it down into one single logarithm. If you have log base something of blah. So go and practice those, and make sure you come back next time. We'll talk a little bit, one of my favorite properties that helps you use those buttons on your calculator for any base, not just base 10 and base E. So make sure you come back for that. See you then.